Good morning, students. Welcome to Business Literacy. My name is Mirha Kahingunga, and I am a senior foreign exchange dealer as well as the head of sales at one of the local banks. As you can see on the cover page is my contact details, as well as with the telephone number and the email address. Business numeracy. Numbers are very important in our day-to-day lives. Numbers are used to calculate an age, time, or performance of a company. I believe that you have familiarized yourself with the coursework in the textbook. For now, we're going to go to and look at working with numbers. Our first question. David earns $80 per hour. If he works 8 hours per day for the next 26 days and his earnings are taxed at a rate of 10%, what will his net pay be for this period? It's always important when you're solving a question that you just write down all of your details. If David earns $80 per hour, and he works for 8 hours per day. He works for 26 days. And the tax on earnings is 10%. Now, what we want to understand here, or what we want to come to, is that we want to know what will his net pay be for this period. Now, there is a formula for net pay. Net pay is equal to earnings less tax. Earnings is equal to earnings per hour times total number of hours worked. Since we've written down all the details of all the information given to us and we have the formula, now all that we just need to do is put the information that we have into the formula. Net pay, I'm just going to abbreviate it by NP. So earnings, as we know, is earnings per hour. Now we know that he earns $80 per hour. And the total number of hours worked is that he has worked for 26 days for 8 hours each. So we say 26 days times 8 hours, because we want to know exactly for how many hours he has worked. Which is equal to $80 Namibian times 26 times 8 is 208, which is equal to Namibian dollars 16,640. This is the total earnings that he makes. As much as we've calculated the total earnings, we have been asked in our question 1 that what will his net pay be? So we want to know what is his net pay. So the second part of this is that net pay is equal to earnings less tax. So if his current earnings is 16,640, we need to also compute his tax, which we know that it's 10%. All right? So if we know that it's 10%, there's also a way to calculate tax, and tax is calculated as follows. We're just going to put something down here quickly. Tax is equal to total earnings times the 10%, which is now the tax that we have been given initially. So if we know what our total earnings is, which is 16,640, times the 10% of that, we'll know that the tax percentage of the earnings is 1,664. Therefore, the net pay is equal to the earnings less the tax. And you know already that we've computed what is our earnings. Our earnings is 16,640 and less our tax, which is 1,664. Therefore, his net pay is equal to 14,976 Namibian dollars. Kindly note that it is very important that whenever you are given a questionnaire that you understand it, that you read it thoroughly with understanding, and that you just write down key points if it is necessary. We're moving on to our second question. In a business mathematics examination, one student scores 90%, 12 students score 63%, and 15 students score 75%. 2 students score 30%, and 3 students score 100%. What is the average of the class? So the question is, what is the average of the class? That is what we are computing. Remember, it's always important that you will write down the details that have been given to you. So we're going to quickly compile a very quick table, because now we're calculating the class average. What I'm just going to start with here, I'm going to put the number of students. Number of students. The percentage score. And the total percentage. One student scores 90%. 12 students score 63%. 15 students score 75%. 2 students score 30%. 3 students score 100%. So once you have written down all your information, now we are going to calculate the total percentage. By total percentage, I mean we take the number of students times the percentage scored. In this case, one student times 90% is equal to 90%. Or we can just say 90 in this case. 12 students times 63% is equal to 756. 15 students times 75 is equal to 1,125. 2 students times 30 is equal to 60. 3 students score 100%, which is equal to 300. The total number of students in the classroom is computed by adding up the number of students here. So if we add up the number of students, we'll notice that there are 33 students in the class. Now we've computed the total percentage here in this last column here. If we add up all the different percentages, we come up to 2,331%. Now what we're trying to compute here is that we are calculating the class average. Now there is also a formula to calculate class average. Class average is equal to total percent divided by total number of students. Now we already know what our total percentage is. We've calculated it. Total percentage is 2,331, which we have there. So we're going to say 2,331 divided by the total number of students, which we have computed here, which is 33 students divided by 33. Therefore, our class average in terms of percentage is 70.64%. Powers and square roots. Question number 3. Calculate the following. 3 to the power of 2, which is 3 to the power of 2 Now practically, what does to the power mean? In this case, 3 to the power of 2 means 3 times 3. Now 3 times 3 is very simple. 3 times 3 is equal to 9. 7 to the power of 3 means 7 times 7 times 7. 7 times 7 times 7 is equal to 343. 6 to the power of 2 means 6 times 6. 6 times 6 is equal to 36. And then D, 2 to the power of 7, meaning 2 times 2 times 2 times 2 times 2 again, times 2. It's actually 2, it's 2 times 2 by 7 times, meaning 1, 2, 3, 4, 5, 6, and 7. And the answer to that is 128. So practically, when we're looking at powers, we are looking at a number times by a certain number of times. In this case, 2 times by 2 by 7 times, and 6 times 6 by 2 times, and so forth. We're moving over to question number 4. Which is negative 2,165 minus 620 divided by 500 divided by 100 plus the square root of 256 minus 6 to the power of 2. Now there's a few very important notes to always take note of when working with equations. Or let me rather put it like this, it's an order of operation. The first important note is that brackets must be worked out first. It's important that you always concentrate on brackets first. Number 2, multiplication and division needs to then be worked out from the left-hand side to the right-hand side. And thirdly, then you add and you subtract. It's very important that you note those 3 very important rules. So if we go to our question number 4, by the rules that I've already mentioned, we need to start working on the brackets first. So we know negative 2,165 minus 620. And then the second part that we work out is the next bracket, which is 500 divided by 100. And then we can work out the rest of the equation. Therefore, in this case, we are trying to compute x. All right? So then first we compute the first bracket. The first bracket is equal to negative 2,785. The second bracket is equal to 5, because 500 divided by 100 is equal to 5, plus the square root of 256. Now, the square root of 256 is 16. You can also use your calculator to calculate the square root of something. Minus 6 to the power of 2, which is 36. Now we come to our next line. Since we've already calculated what's within the brackets and we've calculated also 6 to the power of 2, now we need to also now summarize this even further or break it down even further. Now just by looking at this already, remember it's brackets, then we need to work the multiplication and the division from the left-hand side to the right-hand side. So then in this case here, we are going to say negative 2,785 divided by 5 is equal to negative 557. I'm going to put that in a bracket. And then we're going to plus 16 and less 36, which is equal to negative 577. Working with fractions and decimal numbers. A fraction As you can see on our slide, a fraction, there's an example there of a fraction which is 1 over 4. Now this fraction consists out of a numerator as well as a denominator. In this case, the numerator is number 1 and the denominator, which is now the number at the bottom, is number 4. There are also instances within the financial world where you'll work with decimal numbers. And in this case, this fraction of 1 over 4 converted into a decimal number is 0.25. You also have what is known as improper fractions. An improper fraction is when the numerator is greater than the denominator. We also have mixed fractions. It's a whole number and a fraction together. By an improper fraction, just an example, a written example of an improper fraction. It's when the numerator is greater than the denominator. So meaning, let's say the denominator is 7. So then the numerator must be bigger than the denominator. In this case, let's say 9. 9 over 7. This is then an improper fraction. Then we have what we call a mixed fraction. It's a whole number and a fraction together, meaning what is a whole number? Whole number is a number that is standing on its own. So in this case, we'll give an example of 2 as being the whole number, and then a fraction, we can take a quarter. So then that is what we call a mixed fraction. Question number 5. Remember, we are working with fractions and decimal numbers. In this case, x is equal to the numerator. We have quite a lot of figures up there, but please do not feel discouraged or nervous in any way. It is quite simple. And always remember to always go back to those rules, the order of operation that I just mentioned a few minutes ago. The numerator has 6,982 times 12 divided by 12, while as the denominator has 15,000 plus 21 divided by 2. Times 12 divided by 12, while as the denominator is 15,000 plus 21 divided by 2. Now, just by looking at the numerator, it's always important to go back once again to the order of operation. So meaning that multiplication, in this case over here, multiplication and division must be done from left to right. In this case here, looking at the numerator, we have 6,982 times 12. So what we're going to naturally do is that we're going to put a bracket around 6,982 times 12. And then we're going to divide that by 12. And then we're going to say 15,000 plus 21. That's already in a bracket, so that needs to just be put together. So that will be 15,021 divided by 2. Now we need to first calculate the top part. So 6,982 times 12 is equal to 83,784. And then we also need to divide that by 12. Now 15,021 divided by 2 is equal to 7,605. 83,784 divided by 12 is equal to 6,982 or 6,982 divided by the denominator, which is 7,605. Therefore, x is equal to 0.9181. If we have to round x off to two decimal places, that is, it means that we only take into account the two numbers from the comma. In this case, x would therefore equal to 0.9181. 0.91. Question number 6 says, find the simplest factor for the following. So in question 6a, x is equal to 64 divided by 96. Now, the way that this is just simplification because you're trying to simplify this equation into a simpler form, or you're trying to get it into a simpler form. Now, the first things first that you need to look at is to see, okay, fine, which number can one actually divide into both the numerator and the denominator? In this case, 8 can divide into 64 and 8 can also divide into 96. So then what we're going to do, just to simplify this equation, we're going to say 64 divided by 8 and 96 divided by 8. If we take 64 divided by 8, 64 divided by 8 is equal to 8. Please feel free to use your calculator. And 96 divided by 8, that is then equal to 12. 8 divided by 12 can actually be simplified even further because just by looking at this you can see that you can use 4 to divide into 8 and also into 12. In this case we're going to go a bit further. We're going to divide 8 by 4 and we're going to divide 12 by 4. So 8 divided by 4 is equal to 2 and 12 divided by 4 is equal to 3. Hence this being the simplest form of 64 over 96. So 64 over 96 has been simplified to 2 over 3. Question 7. Convert the following improper fractions into mixed numbers and write the answer in the simplest form. X is equal to 32 divided by 12. This is an improper fraction because the numerator is much greater than the denominator. Therefore, we need to look for a number that, we need to look at this equation and just think, okay, fine, how many times can 32 be divided by 12? So what I'm going to do is that I'm going to say 32 divided by 12 is equal to 2. How many times does 12 go into 32? Which goes in twice. All right? So then we know already what the first part is of this answer. But then, however, what is 2 times 12? 2 times 12 is equal to 24. Now we know that the numerator is 32. So now we want to know, okay, fine, what is 32 less 24? So 32 minus 24 is equal to 8. So if 12 can divide into 32 2 times, now we're computing our answer, and we've also found out that 32 less 24 is 8. Then we know that the answer to our question, or we're looking for the mixed number, is 2, and then we need to know the fraction part, which is 8 over 12. However, 8 over 12 can still be simplified even further. We can divide 8 by 4, and we can also divide 12 by 4, meaning that our fraction then changes, because 8 divided by 4 is equal to 2, and 12 divided by 4 is equal to 3. So then we have now computed our mixed number in the simplest form. A way that you can also check whether you are, whether your answer is correct is by looking at is by actually doing a reverse calculation. By doing a reverse calculation, I want us to concentrate on this part over here. All that then you'll do is that you'd say 12 times 2 plus 8. Now 12 times 2 already is 24, plus 8 is 32, which would then be 32 over 12. That is how you check yourself to make sure that yes, your answer is correct. Question number 8. Convert the following mixed fractions into an improper fraction. X is equal to 7 and 8 over 12. So this mixed fraction needs to be converted into an improper fraction. Now just think back of question 7 that we just answered now. If you think back to that, then you will already know how to change this specific fraction into an improper fraction. We are going to take 12 times 7, 12 here, times 7, and then we are going to add 8. Twelve times 7 is equal to 84, plus 8 is equal to 92, because we are trying to compute, by this whole calculation in blue, we are trying to compute what the numerator is. So in this case, we know that 92 is what we call the numerator. If we have the numerator now, and we know already what the denominator is, we can complete our answer. So we say 92 divided by 12. And this is our improper fraction. Question number 9. Find the answer to the following problem. X is equal to negative 4, 7 over 10, plus 2, 4 over 5, plus 2, 1 over 10. Now, first things first, when you have an equation that looks as such, you first need to change these mixed numbers into improper fractions. This is how you do it. Remember that if you want to change a mixed equation into a mixed fraction into an improper fraction, you need to take the denominator times the number in front, which is in this case 4, and then we're going to have to add the numerator. But then before we even get there, we need to make sure that all the denominators are all the same. In this case, we see that we have a difference here. We have a 5, while as in all the other numbers, in all the other fractions, we have 10s. Okay? But then anyways, we're going to first do the conversion to an improper fraction. So if we say 10 times 4 is equal to minus 40 plus 7 is minus 47 over 10. 5 times 2 is equal to 10 plus 4 is 14 over 5. 10 times 2 is equal to 20 plus 1 is 21 over 10. Okay. Now, already by looking at the fractions that we have there, we'll notice that we don't have the same denominator in this specific fraction here. So we've got to change this so that it's exactly the same as all the other denominators. In this case, the other denominators are tens. So what we're going to need to then do, how do I get to 10? I need to multiply 5 by 2. So we're going to multiply 5 by 2. And remember, whatever you do to the bottom, you do to the top as well. So 5 times 2 is equal to 10. And 14 times 2 is equal to 28. So we're just going to quickly rewrite our equation as such. Sorry. So it's minus 47 over 10 plus 28 over 10 plus 21 over 10. Because all the terms within this equation must be like terms. In this case, all our denominators are now equal to 10. Now the next thing that we need to do, since now we all have the same denominator, is that we need to add up this equation. So if we take negative 47 over 10 plus 28 over 10 plus 21 over 10, we come to 2 over 10. However, this must be simple. We're trying to simplify it even further because it can be simplified further. In this case, we can divide 2 into 10 5 times. So what we're going to do is that we're going to simplify it by dividing by 5. Sorry, by dividing by 2. Sorry, my humble apologies, by dividing by 2. So if we say 2 divided by 2 is equal to 1, and 10 divided by 2 is equal to 5. So then our answer is equal to 1 over 5. We're going to move on to question number 10. She's on the next slide. Steve weighed 120 kilograms in January 2013. He made a hard decision to diet in February 2013 and lost a third of his weight. How much does Steve weigh after losing weight? So we want to understand, what we want to know is that how much does he weigh after he has lost some weight? Using fractions. So it's always important, firstly, always write down your details. Write down what has been given to you. In this case, we know that Steve weighs. We know that Steve's weight is 120 kilograms. This is in January 2013, all right? And he lost a third of his weight. That's number 1. Number 2, he lost 1/3 of his weight, which we don't know exactly what that 1/3 is. So we'll call that 1/3 that he now lost. We're just going to call that is equal to X. Okay. Now, we're first going to compute how much did he lose, because in order for us to compute, what his actual weight is, we need to first know how much has he also lost based on the information that has been given to us. So we know that in January 2013, he weighed 120 kilograms, and then he lost a third of his weight. So we also use equations with fractions to calculate weight and all other interesting things. So in this case here, we're going to take his weight as at January, which was 210 kilograms, because we want to compute what has he lost. So it's 120 kilograms times a third of his weight. Okay, because a third is what he has lost, which is equal to 120 divided by 3, because if we take practically this 120 kilograms means 120 over 1. So if we multiply it by 1 over 3, it means 120 over 3. So if we take 120 and we divide it by 3, we'll come to 40 kilograms, meaning that Steve lost 40 kilograms. So a third of Steve's weight is 40 kilograms. If Steve lost 40 kilograms, now we want to know exactly how much does Steve weigh now. So therefore, we're going to take his initial weight, which is 120 kilograms, minus what he lost, which is 40 kilograms, less 40 kilograms. That will equal to his weight now at this point in time. So 120 less 40 is equal to 80 kilograms. Steve therefore weighs 80 kilograms. Steve's weight is, 80 kilograms. Because he's already lost 40. Initially, he weighed 120. So if you take 120 less 40, now we know that he weighs 80 kilograms. Question number 11, convert the following mixed numbers into decimal numbers. X is equal to 6 and 2 over 4. Remember that these are mixed numbers to be converted into decimal numbers. Okay, we have A and we have B. X is equal to 3 over 11. You can also use your calculator when calculating all of this. But to convert 6, the first one, which is 11A, what this practically means over here, it means 6 point. If you always look at it like that, it will always be simpler to you. And if you take 2 divided by 4, it's equal to a half, isn't it? Because if I have to divide 2 by 2 and 4 by 2, I would get 1 over 2. So in this case here, the answer to this is 6.5. Because 2 divided by 4 is equal to 1, because if I take 2 divided by 2, then I'll get 1, and then 4 divided by 2, I'll get 2, which is a half. A half is equal to 0.500. So in this case, the answer is 6.5. In order to calculate 3 over 11 from a mixed number to a decimal number, you would then say 3 divided by 11. That's how you'll calculate it on your calculator, which is then equal to 0.2727. Convert the following decimal into a fraction. Now the decimal is 0.0250. 0.0250. That is a decimal that we now need to convert into a fraction, meaning that when we convert it into a fraction, it should have a numerator and a denominator as well. Just a quick trick: whenever you see something that looks like this, a decimal fraction, or whenever you see a decimal that looks like this, you already know that after the comma we have 1, 2, 3, 4 movements. All right, so then we can look at this and say, okay, fine, whatever it has must have 4 zeros below it. So by this I mean, if I take 250, by this I mean that with the 4 zeros, I mean that, let's say if the number was 250, let's say if this number, let's just do a separate line here. Let's say if this number was 250, all right? And then I just need to convert it into, I have to convert it to get it to 0.0250. I'm just working it the other way around so that you understand the logic behind it. Then you'll know that, okay, fine, how many zeros, if we look at this over here, we'll know that there's, after the comma, there's 1, 2, 3, 4. There's 4 movements, or 4 movement of decimal places. So if I have to move from here till there, I'll move 1, 2, 3, 4, isn't it? Which is now equal to this, because 0.0250. If I have to put a 0 there, I'll put it in as such. So it's 0.0250, which is what we have here. So by doing this, I would say, okay, fine, in order for me to get 0.0250 to 250, I would need to multiply it by 10,000. But then at the same time, that's not actually what we are looking for. What we're looking for is that we're trying to get this 0.0250 into a fraction. So in order for us to get it there, what do? Rule number one, we always try to count the decimal places, okay, or the places after the comma, and there's 4 of them. And remember that these are like it's 250 over 10,000. We can also check whether it's correct. If you take your calculator, because remember, just a quick one, just to maybe quickly show you something as well so that it just makes sense in your logic before we come to answering this, is that if I'm to take 10 divided by 100 and I use a calculator on it, right? I'm going to come to 10 divided by 100. So I would then need to say, okay, 10 divided by 100, and you know that after 10 there's a point, right? Because 10, we take it as a whole. Divided by 100, I move by 1, 2. So then my comma moves in here. So then meaning that 10 divided by 100 would then be equal to, if I put in my zeros there, 0 point, sorry, not this 0 here. It would, by 100 is equal to 0.10. That's what it would be equal to. Sorry, let me just shift this a bit up. So 10 divided by 100, as I was saying, we would say we have the number 10, and it's a point. So if we have to divide it by 100, we have to move 2 places. We have to move 2 places behind it. So what it's place number 1 there, place number 2 there, we put the comma there, is equal to 0.10. So I hope if you understand this logic, then you can also apply it here as well. So 250 over 10,000, that is actually our calculation. That's the fraction that we have computed, which is then correct. But then at the same time as well, I'm also thinking that another way that you can always check yourself is that you say, okay, fine, 250. What's 250 divided by 10,000? Meaning that I must move 4 zeros back from this point over here. So meaning I would say 250. We're just checking ourselves whether our answer is correct. It's a point, right? So we need to move 4 places back. So it's 1, 2, 3, 4, which would then equal to 0.0250, mean that our answer is correct. If we have to convert this decimal into a fraction, it will be 250 over 10,000, like what we have there. Unfortunately, due to time, we were not able to actually cover all the different parts of business literacy. But what I have done is that I have compiled a few questions as well as a few notes that you can go through so that you can familiarize yourself with certain concepts. For example, simple interest and compound interest, the break-even analysis, where you use, when it comes to using interest rates in business, how to use them, how to calculate interest rates, and so forth. You'll also notice that within the notes, we also cover the Pythagoras theorem as well. So you can also go through that to understand Pythagoras more. And most importantly, what I've also done is that because I wasn't able to, or in this session, I wasn't able to cover the business communication part. What I have done is that I've also compiled something for you, which then will be distributed out to you, where you'll, touch more based on the communication when it comes to spoken communication. And also on those notes, you'll notice that I also have some questionnaires that you can also go through to complete. Just a final word is that business literacy is very important, especially if you have the plans to step into the business world, because when you step in the business world, it has its own language, as it says, business literacy, in its own ways of expressing itself. So it is also very important that even as you go through these notes, that you understand it and that you just familiarize yourself with it, because when you get into the working environment, you'll notice that a lot of these things are things that you come into hand in hand with, or you come face to face with.